Okay, morning. How's everybody? All good? Awake? Good. Okay, so today the idea is that we talk about a little bit of a review of programming 1. Okay? So you're gonna try to see if you have any difficulties with C#, with the basic of C#. If you do have, again, use this time now to assess yourself and see, because what I'm going to be talking about in the first half of the class is very basic stuff about C#. So if you feel that you are having problems understanding this review of basic stuff, let me know, because then I'll be able to share with you additional resources that you can catch up on the basics of C#, okay? Because this course will not cover the basics, but this is a quick review. Again, stay tuned, and if you have difficulties, let me know, and I can help you with additional resources, okay? Okay, so what do you think is the most important concepts the information technology has developed? I don't know if you have seen the PDF already, but what is it? I use this quite a lot. Copy and paste. I use this quite a lot. You're going to see me copying and pasting because, as I said, I don't believe in memorizing stuff, okay? I believe in understanding. So if you understand, I mean, that's fine to copy the namespace, to copy something. I mean, you don't need to have everything on top of your head. You need to have things accessible. Oh, I know where to get this. I know where to find this. I know where to find that. You have to have your library of knowledge. You have to get to know how you can find that the answer to that question, but Control-C, Control-V. Okay, so this is by no means an extensive review of C#. It's a very superficial one, just with some basic concepts that you're gonna need to get this course going. Okay? I'm gonna just really focus on what is most important here. But before I get to the content, I want to hear from you. If you have done programming 1, or if you have not done programming 1, but you have some programming experience, what comes to mind, what words comes to mind when you think about programming 1, or when you think about your coding experience in general? Let's go to that Padlet, and as I said, you're going to be using that quite a lot. I want you to start throwing your experience with programming 1 or coding in general. Come on, give me a few words there. Good morning to you too. Okay, what do we have there? That's fine. If you did not take programming, that's fine. But if you are in this class, you have to have some experience with programming. So give me a little bit of your experience with programming. Is it hard? Is it easy? It comes naturally to you. What if I don't know about C#? Well, this is programming 2, okay? So as I said, if you have problems with C#, what I'm going to do is I'm going to, actually, regardless, I'm going to share some resources under week 1 that you can recap, review, or learn the basic of C#, okay? So I'm going to put there. So you don't need to tell me. You can access those resources. I didn't put them yet there. But I'm going to, in the afternoon today, I'm going to put some links there that will allow you to have a recap, review. You know, again, you may not know a lot of C#, that's fine. You may know concepts about coding in other language, that's fine as well, okay? If you have concepts from other languages, that works too, okay? It will be hopefully easily transferable to C#. Let's see what else here. The beginning was hard as a new learner. Okay, I get it. Okay, class methods and objects. Okay, that's really what we're going to be talking about in this class here. Classes, objects, and methods. Okay? So if you know that already, you can help out. You can help the ones that might be having difficulties there. Write line, read line, yes, you're going to have that as well, object-oriented concepts. Always leave comments when you do coding, otherwise you won't even understand. You're right. You're right. Comment your codes, because if you revisit a few months down the road, you won't know what's going on anymore. You'll forget that. I forget a week later. Love data structures. Wow. Okay, good. Everybody, has their own loves and hates. Great that you love data structures. Still have a problem about parameter array. Great. I have that as well. Hopefully you're going to have a look at parameter array today as well. Python user, okay. Python, very hot language out there. Everybody wants Python. Everybody wants machine learning, AI. Just be careful, because everybody's there, so it's very crowded as well. Okay, but again, that's fine, all good. Then take programming 1, then code in C#, but knows PHP. MySQL, real life project experience, that's great. MVC, if you know MVC, you're gonna be good for web application development. So again, those people that are saying that they know MVC, Java, things like that, you can help me. You can help me. I need your help. What is the similarity between C++ and C#? To be quite honest, I have not coded in C++. I can tell you that C#, from what I've seen, from what I've observed, is easier than C++. C++, I'll tend to think of a more, I would say that's a lower level programming language, but it's not as simple, straightforward like C#. Okay? You have to understand more details when you go to C++. You are closer to the machine. C#, you can think that you are further away from the machine. C++, you are lower, you are very close to the machine. Not too close like assembly code, but closer than C#. Do we have complex code in C#? Not for this course, to be quite honest. We'll be talking about object-oriented programming concepts in general. So I tend to think that they are not too complex. But again, it might be just me with my bias of knowing the course contents. It's really about complexity. Is in accordance to who's asking the question. It might be complex to you. It may not be complex to the next person. Okay. Okay, what else we have here? Had a course on object-oriented programming with C#. Great, so you have some knowledge there. That's great. If then else, if and else. What if we don't know? Okay. I think that's we're good here. Great. Think for that. I just wanted to get a feeling here of what's going on. Okay, let's talk a little bit about the book. I don't have it with me here, but I'm going to be following the book. You don't have to buy it, to be quite honest. I will be always providing links to resources that you can find freely on the web. Okay? If you have the book, it's a great resource. It has plenty of exercise. Are we going to practice all the exercises from the book? No, we are not. But if you're inclined to do so, if you have the book, if you want to go through the exercise, if you get stuck, let me know. But again, we're not going to be able to go exercise by exercise from the book. However, if you have it, and if you want to dig in, the point is, one of the points that I want to make it clear is that this course will cater for who's starting and who's also advanced. If you are more advanced and you want to dig into exercise, dig into the book, you can do that, and you can count on me. But I will be covering the most important aspects here. And some of those things, as I saw in the answers there, they might be basic for you. For some of you, they may be not. But I want this course to be useful for everybody. If you're advanced or if you're basic, I'll be catering to the middle there, okay? If you're advanced, come to me with your questions, and most likely I won't be able to go through each and every single example here. That's why this is a cooperation effort. Okay? I just want to get a feeling here of who has the book and who intends to get the book, just so I can have a quick count here. Nearpods, go to this code on your pods. Let me just hide your names. Here's the code, nearpod.com. I'll give you a minute. Give it a try. I just want to see who has the book, who is planning to get the book. Digital formats, hard copy, doesn't matter. Yes. Sorry, I just can go back here. So nearpods.com, that's the site. It asks for a code at the top, and here's the code. Okay, so let's have a look here. So, okay, half of the class doesn't have the book. Well, way over half of the class. That's fine. Again, as I said, it's useful. If you want to go for it, that's fine. If you don't, I'll have plenty of links. Now, the only thing with links is that you're going to be jumping to the site and jumping to that site and jumping to that other site. There is no single site that I'll be covering all the content from. The book is a central point. The links are all spread here, there, over there, over there. It's a video here, it's an article there. So again, if you don't have the book, be prepared to be jumping around to get the content. But I'll be providing that, okay? Any questions about that? Yes?
There is no PDF file of this book?
There is no PDF? I don't know. I don't know. Okay, coming back here. So what we're going to be talking about today, chapter 1, 2, and 4. This is the review. Again, very brief, very superficial, you're going to see in a second. Chapter 8, we're going to be talking about that in the second half, and it's about methods, about advanced method concepts. We're going to be talking about parameters, mandatory, optional, okay? We're going to get there in the second half. So 1, 2, 3, 1, 2, 4, there. Again, I'll focus on what's most important. We all know that code is a bunch of zeros and ones at the end. What is a compiler? Who can tell me what is a compiler?
Source code and generates it into machine.
Yes, that's about it. It's a piece of code that will read the high-level language code, which can be, in our case, what is it? C#. It will convert that code into machine code, which is usually what type of file gets created? Extension. Let's think about extension. What is the extension of the generated file? Usually. It can be many, but when you compile a C# code as a, let's say in our case here, you're going to be using the console application. What type of file gets created? A dot what? Nope. Dot? exe. What is the exe? An executable. So it creates a runnable code. Okay, so you can double click and it runs. Okay, so that's what it creates. And then you run the program. In the program, any application out there, doesn't matter how simple or complex, it will have those two elements. Methods, they have those two elements. You enter something and it gives something out. That's really it. Let's think a little bit about devices and places that now we can be coding for. We can be coding for so many different things right now. 12 years ago, 15 years ago, we had the computer and that was it. Today, what is it that we can code on? Come on, give me some examples here. Computer, still one, laptop and all of that, but what else? Mobiles, what else? Tablets, what else? Think deep. I mean, go to the present moment, present day. I mean, think about your homes. Think about what is smart in your homes. What is smart out there? Come on. Smart TVs, yes. What else? Washing? Washing machines, yes. Actually, a friend of mine, not washing machine, but it was a fridge. She can go to the supermarket and she can check what is inside of her fridge from her phone. She can have a snapshot of what is inside of her fridge when she's there. Anyway, crazy stuff. What else?
Control the lighting system of the lighting system.
Lighting system, yes. IoT. Think about those small devices that we can talk to. Google Assistant, Google Home, Alexa, all of those devices. Now, the jobs that you're going to be working for in 2, 3, 5 years, you're going to be coding for those things. Your code will be expected to run. This running thing here will be a smart device. You're going to be having to accept inputs, not only from the keyboard, but what other inputs you're going to need to accept. Think about what other inputs. Voice commands. Gesture. Okay, so again, all of that, this is not futuristic stuff. This is here right now. Okay? So again, and hopefully we can get ready with that. .NET Framework, I'm not going to hammer on this. To be quite honest, .NET Framework is not the focus of this course. That's the only slide that has .NET Framework there. Microsoft has, in a way, moved on to .NET Core, but the concepts that you're going to be talking about in this course and the practical examples are applicable to .NET Framework, to .NET Core. You're going to be studying .NET Core next semester on web application development. This is, a framework means that it's a bunch of pieces working together to make something available to the coder. Now, and we'll be coding, of course, on C#. Okay, using Visual Studio. Okay, not going to hammer on that too much. I want to focus on the second statement there. High-level programming language, because we are coding, we are talking in semi-English there. It's if, else, while, for. So again, that's why it's called high-level. What does it mean to be, welcome? What does it mean to be a strongly typed language? What is strongly typed? What is type? What is type?
Writing, coding.
Huh?
Coding, writing.
Coding, writing.
That is about a variable type.
So,
the kind of data a variable can handle.
for instance,
Integer, float.
so those are types, correct? So strongly typed means that when you declare a variable, you have to say what is the type of that variable up front. You cannot keep it unknown. It has to be known from the start, from the beginning. So that's why it's called a strongly typed language. You have to declare the type. Even though we have var in C#, but it does not mean that it doesn't become strongly typed, because right after we use a var, we assign a value to that var, and at that moment, we are defining the type implicitly of that variable, okay? But that's why we say that C# is strongly typed. Lower this thing here. Okay, any language, any coding language, any programming language, they have those two components, keywords and syntax. What is keywords? Look at this mug here. Give me some examples of keywords in this mug. New is a keyword. What else? If is another keyword. Else. Dot. What about this? Var as well. Okay. So those are keywords. Those are the words that you use in that language. Keywords. And what is the syntax? The formats. The format that you put those words together. Like English, I'm speaking one word after the other, but I have to speak them in a certain flow to make sense. So we have a syntax, okay? What are some of the elements of syntax that you can see again in this mug? Brackets, okay, so curly braces here. What else? Semicolon to indicate what? End of the line, okay? So what else we have here in terms of syntax? The new here, it equals to new. This is how you create a new object. Okay? So that's correct. So again, those are the elements. Like when you call a method, you use parentheses there. Okay? Those are the elements of the syntax. Okay? Okay, C# is case insensitive, correct? Yep. Case insensitive. What does it mean to be case insensitive? What does that mean?
We can write as well as in lower letters or the uppercase letters or lower letters.
Except both, correct? Doesn't matter. Does it matter or it doesn't matter? It doesn't matter. It does it? It does matter. So you're saying that the slide is wrong? Yeah? So you're saying that what I'm teaching is wrong? You're correct. C# is not case insensitive. It's not. Okay? If like this, it's different from this. Actually, you cannot type like this. You cannot type like this. You have to use it like this. So C# is not case insensitive. C# is case sensitive. I'll be doing this quite a lot to catch you. And I caught a lot, but not some. Think for that. So again, C# is case sensitive, which means that capital and lowercase are different things. Okay? If you can have a variable declared uppercase and another variable declared lowercase, they are different. Okay? So not insensitive. Let's have a look at some types. Int, double. What other numeric types do you have available in C#? Floats. Double is there. Long. What else? Decimal. What else? Which one? Array. Array? Okay. Okay. Array is a array. You can have arrays of different types. So yeah, it's a type as well. Okay, so numeric ones, we have those. Character-wise, we have characters with one character only, and then we have strings with a kind of an array of characters. And we have booleans, okay?
Do we have short and
Short? Yes.
Short is long.
Short, long, we have all of that.
There and signed and unsigned.
Yes, we have, again, there is a long list of numeric types, okay? So, the first line is the same as the second line, or are they different? And would the code compile if you see that in the code? Would it compile? It would.
It would compile,
Because-
but it's like standard of writing that very
Oh, we're going to talk about standards in a second. So what you're talking about is casing. So we're going to talk about that in a second. Good point. But without thinking about standards, both of those lines would work, and they can be in the code at the same time. It's acceptable. There will be no compilation error there. Okay? So, this line is the same as this one? No. What is this line here doing?
just assigning the value to the variable.
Just assign the value, yeah? What is this doing?
Comparing the value.
We're comparing the value. Now, this line here will not compile. Just like that, because it will not understand what that is. Where can we use this comparison here? Where?
If we define the
In an if statement. We could assign this to a Boolean type. We can say Boolean b equals to age. Is age equals to 21? And then it will return true or false. Okay? So they are not the same. Let's give this a try here. Let's go to, I think I have a few questions here. Basic questions. Just as I said, this is a recap. Basic recap, initializing variables. Nearpod again. This is the code. Give it a try. I think that we have 4 questions there. So here is the code. While you do there, that, I'll just take attendance. Ahmad? Ampreet? Anu Biju Kumar? Yep. Brandon? Brandon? Kai Zhang? Danny Fu? Danny? Fábio? Jaden? Verma? Jaden? Is that pronounced correct? Jatin? J. Dave? Jiangsu Zhu? John Avenido? Luana? Lufu Liao? Okay, Manpreet, Marvin Dilara, Mehmet Osmar or Ozamas, yeah. Mukahit Arik, Mukahit, Rahul Raman, Ravi, Ricky, Ritesh,
Yes.
Sali, Sitak, Sampath, Sanchit, Sim Dilon, Siruthi Gali. Yep. Steve Huang.
Yes.
Thierry Kine. Is that Kine? Tomoki. Vin Trong. Wanida. Yen Yu. Jim. Yogsi Kin. Zangir Asilbekov. If I missed any names, let me know, please. Okay? Okay, let's have a look here. Okay, this is wrong. Did I show? Oh no, this was not the right one. Okay, sorry about that. I had a different window open here. But yeah, if I ask you to go to a link and the questions don't make sense, it's most likely I gave you the wrong link, okay? So let me know. Okay. Again, as I said, basic, but I think it's a good recap. So what values can be assigned to an integer variable called angle? A. Is A okay? 180 is an integer, correct? How about B? What is the problem? It's, what type is that? A decimal, a float, a double, okay? So you cannot assign a double to an integer. It cannot convert implicitly, okay? So it doesn't work. Okay? Even if it was 100.00, it would still doesn't work, okay? How about C? Can we have negative numbers as integers? Yeah, we can, okay? How about D? What is the problem with D? It's a string, and again, there's no implicit conversion of that. We'd have to convert that. How could you convert that? Anyone? How would you convert a string to an integer? What is that? Type with casting. There are different ways to cast. Okay, very different. We can use try parse, parse, convert. A bunch of different ways. What is the problem with E? It's a character. Why is it a character? Single quotes. But when you use single quotes, can we use a string? One single character, correct? So E would not even compile, okay? Because it would say this is invalid. Okay. Okay. What if we change angle to double? What if we do that? What A is still valid? Yeah. You can. It's 180 is an integer, so you can implicitly assign an integer to a double, to a float. Okay. How about B? That's a double. How about C?
Is valid.
It's valid. And then we have D and E, which will fall into the same problem as before. Okay. By the way, before I progress, let me see how we have done here. So, okay, those questions are supposed to be basic ones, okay? And I understand that when you have multiple choice questions, that you can select multiple, becomes a little bit tricky. But again, if you have difficulties with those questions, again, you're gonna have to have a look at the basic C# resources that I will be providing, okay? Under week 1, I'll be clearly labeling them. So, next one here, we have a string. Well, I'm already giving the answer. So, which of the following declares a variable that can hold the word computer? Which one is the valid one? B, string device, and then we assign the word computer. The problem with A is single quotes. The problem with C and D, they are characters. They are characters, and they accept just one single character, okay? And when we are dealing with characters, we deal with single quotes, not double quotes. And what is the type of a variable that can hold the two values true and false? D, Boolean, okay? Okay. Okay, let me play this quick video here. As I said, this course is focused on object-oriented programming. I just want to put somebody else's voice out there so we can understand a little bit what is the difference, what is the other approach, the older approach to object-oriented programming, okay? By the way, all those links are functioning on the PDF that I uploaded to Centennial under week 1. So you can open those PDFs and you can click those links. They will point to the correct videos.
This wasn't always the way. My first programming job was writing assembly language, COBOL, and other programming languages developed in the last 30 years are all object-oriented languages. But this wasn't always the way. My first programming job was writing assembly language, COBOL, and Fortran on mainframes. Now, these were not object-oriented languages. They were straight procedural languages, where the program is written as a long procedure. Now, it might contain named functions and subroutines to make it more modular and maintainable, but it's really a long piece of code. often with all the data, all the variables defined in one place, and all the logic in another. But as programs got bigger and bigger, this proved to be difficult to manage, difficult to plan. And object-oriented languages started to gain popularity in the 80s. Now, in an object-oriented language, this one large program would instead be split apart into self-contained objects, almost like having several mini programs, each object representing a different part of the application. Now, each object contains its own data and its own logic, and they communicate between themselves. Now, the idea here is that these objects aren't random. They represent the way you would talk and think about the problem you're trying to solve. They represent things like employees, images, bank accounts, player objects, spaceships, asteroids, video segment, audio files, whatever exists in your program. So object orientation is what's referred to as a programming paradigm. It's not a language itself, but a set of ideas that is supported by many languages. But is there an alternative to object-oriented programming? Well, yes and no. There are other approaches to programming, not just procedural languages like straight C, but if you go through a university computer science course, you might work with logic programming languages like Prolog, or functional programming languages like Haskell. But these do tend to be more popular in the academic world or with very specialized uses like computational linguistics. But if you're working or want to work in the practical, pragmatic world of creating web applications, mobile apps, desktop applications, game development, you will be using object-oriented programming languages. And your only real choice is, do you know what that means or not? So the first question, if everything we do in these languages is object-oriented, meaning we're oriented or focused around objects, exactly what is an object anyway?
So, what is an object? Anyone?
Instance of class.
Is a?
Instance of class. Instance.
Okay, that's the technical definition. It's an instance of a class. I'll keep the question. What is an object? Just in a high level.
Anything that has like its own functionality.
That's correct. That's good.
Object we can call any method.
We can call methods from object. That's good. So I tend to think of it as a representation of a real life entity, thing, object, like a student, an instructor, a bank account. Some are concrete things, and I like the definition of that a student gave the other day. It's the representation of a tangible thing, something tangible like a bank account, like a student, like an animal. So that's what objects are, and that's what we're going to be talking about quite a lot here, how to do that in C#. Let's talk a little bit about casing. What is casing? What is casing? That's towards what you mentioned before. You were talking about uppercase, lowercase, about standards. Casing is about how you standardize the way you name things, okay? So different companies will have different styles, but we start somewhere. And this is a very popular style. Those two are very popular. Camel casing and Pascal casing. What is camel casing? Who can tell me what is camel casing? And again, camel casing is the same, whether in C#, in Java, in PHP, it's the same thing. It's just a general concept that applies to any language. What is camel casing?
The first letter is small and then every word has a capital.
That's it. That's it. So you have a hump. You start small and then you go up, and you go up, and you go up. That's why it's camel casing, because of the hump of the camel, okay? So camel casing is used for local variables, for private fields. I'll be a stickler about following conventions, okay? So have a look at this and let's apply that, okay? I want to see a beautiful piece of code here, okay? Pascal casing, what is Pascal casing? The only little difference between camel casing and Pascal casing is what?
First letter is small and first letter is capital.
Yes, that's it. So first letter in Pascal casing is capital as well. That's it. And where is applied? It's applied for naming classes, for naming methods. Okay. And again, I really want to use that on our codes. Okay, good chunk of our course will be based on console applications. Yes?
Sir, how about when we declare a variable, we use underscores. So, for example, a letter, then underscore, then again letter, but all with small cases. How about that?
Well, that's another standard that could be used. It's not really the Pascal nor the camel casing.
But I personally used to use that.
As I said, different companies out there, different people out there will have different ways of doing things. For instance, I see a lot of private variables being declared with underscore, the name of the variable. Again, for this course, I'll be applying those two standards. There's no right or wrong here, really. It's about having a standard. Yeah, there's a name for that. If I'm not mistaken, that is called snake casing, if I'm not mistaken, because I think it is. But there is the standard as well to use underscores or underline, however you want to call it, between words. No, it's just another standard that is as valid as those. Okay, so as I said, a good part of our course will be done in this black window. Very boring, yes, I know. No colors. But hopefully in the last 3-4 classes, we're gonna have a look at some GUI, some Windows application. So we'll make things a little bit prettier. But initially, because the concepts can be applied to anything, we don't want to overcomplicate with complex UI. Our UI, our input and output, will be just the command line. Okay? What is the command line? What is the command line? Or how do you access the command line on Windows, for instance? What do you type to get to it? CMD. So you have the command line. Okay? So our applications will be very basic, very simple, from a user interface perspective. Very boring. But that's okay. That's okay, because we are going to focus on OOP, object-oriented program, not so much in the graphical applications. Okay? IDE. What is IDE? What does it stand for? IDE. Integrated Development Environment. Just a fancy word to say it's a text editor. It's a fancy text editor. Now, Visual Studio is very powerful, a very powerful text editor with a lot of automation there. As students, you can download Visual Studio for free with your login credentials to somewhere. I don't recall on top of my head, but I'll make that link available on the Centennial under week 1, so you know that you can download Visual Studio on your laptops. On the workstations, you don't need that. It's already installed. It doesn't matter if you use Visual Studio 2017, 2019. It doesn't matter. What you're going to be doing can be used, can be done in both of them. Even if you have Macs, that's okay as well. You don't need to have a Windows environment to get that working, okay? We're not going to be going after complex libraries. Now, towards the end of the course, you're going to be doing some graphical user interface. For that one, yeah, Windows will most likely be necessary, okay? Just a heads up. And for the next course as well, web application development, you may need that as well. But again, it doesn't matter if it's 2017 or 2019 or 2015 for that matter. So, quick summary here. As I said, this is also a brush, just our first half, not too much details overall, but you now have the feeling whether or not you need extra help with C#. I saw that some people need that. And again, that's why I'll be sharing those additional resources. C# is a high-level programming language with keywords and syntax, case-sensitive, not insensitive. And we have a bunch of types there. Our IDE is Visual Studio. I have not been checking our Padlets that often, so I don't know if people are asking questions. Let's have a look here. So, okay, so we have some questions here. Let's have a look here. Maybe this was from before, but let's see. Had a course on object-oriented. No, I think this was before. What is the similarity between C++? I mentioned that I have never coded on C++, and it was a little bit, C++ is more, it's closer to the machine code. Yep, there's nothing here really. So, any questions? Okay, so let's go for a 5 minutes break. Once we come back, we're gonna have a look at methods, okay? 5 minutes. What's up?
Is it possible to decrease the brightness of this?
Decrease the brightness?
It is killing my eyes.
Okay, so let's have a look. I'll try, okay?
So when you were taking attendance, you took my name twice. So I want to know which actually Amanpreet is. Can I know the ID?
Amanpreet C?
Yeah.
Is that yours?
Yeah, I don't know. I think there are two on.
True? Okay, let's see. Nope.
No. Okay, so it's Amanpreet.
Amanpreet.
Thank you.
Yep, okay.
Textbook, but I found the textbook for 2010 Micro Visual Studio.
For what?
2010 Visual Studio.
If that's the same book, that's the same author, that's okay.
Yeah, it's the same
Yeah,
author,
that's
so
okay.
It's not 17. It's
That's okay. That's okay. Okay?
difference between C# or Java?
C# or Java?
Like different companies develop it.
Yeah, but I mean, syntax, they are quite similar. You know? They're
thought
quite
it.
similar, yeah. I mean, I've never programmed in Java, but actually, I have a certification in Java, but I never did professionally. So it's very similar syntax. You know?
Like it will be not difficult for you.
No, it won't. It should be fine. Okay? Just try something here. Okay, so I've tried my laptop. I could not control from my laptop. I've tried Napoleon there. I could not see how it works. Now, here's what I'm going to do. Once I'm done, for the next class, I'm going to call the technical support to try to figure out. Okay?
Thank you.
Sorry about that. Yes.
About the case for the variables, I just wanted to know about the industry. I mean,
Yeah.
I know in India, I mean, I did work in a small company.
Yep.
And I did freelancing. I wanted to know about the standards, what the industry amount. I mean, I am focusing on the big industry, that's why I'm here.
Got it.
So, I want to know about the standards which big companies are doing for the cases and all that.
I tend to think that what I shown here, Pascal casing and camel casing, are very widely used. Okay, so if you can, practice that, adapt.
It doesn't matter to me to
I get it.
add on. It's just about following the standards so that everyone can understand my code.
Got it. And again, it doesn't mean that everyone is following that, but I see a lot of companies out there using that. Okay. Awesome. Okay, let's carry on here, please. Okay, so we'll be talking about methods, advanced method concepts. Basically, what is a method? Just first thing that comes to mind when you hear the word method. A function. What else? Anything else? A set of codes, yeah? Hopefully not that long, because if it's too long, you're better off to breaking it down into additional methods, okay? So I used to think about function I used to call when it returns a value, and method when there's no return value. That's the way I think about methods and functions. But again, today, currently, we don't use the name function too much anymore. It became a bit of old-fashioned, okay? So what we're going to be talking about today, methods in general, but more specifically about parameters. What is a parameter when it comes to a method? What is a parameter in the context of a method?
A set of
Arguments which we can pass.
Remember that program that has inputs and that has outputs? A method is a little program that has inputs and it has outputs. It does something. It does, again, if it doesn't do anything, it wouldn't exist. So it usually takes something in and it does something and it outputs something out. Nowadays we have all kinds of crazy ways to create methods. We have something in Azure. Who knows what's Azure? Azure, anyone? Microsoft Azure? Yeah, what is that? A cloud platform from Microsoft. Yeah. So now we can create little methods that you can put in these clouds that you can call them, those methods, from anywhere. So again, just expanding a little bit on that concept. Yesterday I was in a meetup, a .NET meetup in downtown. They were talking about that kind of stuff. Okay, so yes, methods, they have parameters. Maybe some methods won't have parameters, that's fine as well. But we're going to be talking about the different parameters that we can have in a method. We can have, overall, in general, we can have two types: mandatory parameters and optional parameters. Well, the names are pretty much clear. Mandatory ones, you have to send something. Optional, you don't. That's really it. We're going to talk about mandatory, most likely. We may not get to overload today, but that's okay. It's okay. Now, when it comes down to mandatory parameters, it has 4 different types of mandatory parameters. So forget for a second optional. We are just talking about mandatory parameters here. We have 4 types: value parameters, reference parameters, output parameters, and parameter arrays. Okay? 4 types. And I'm going to go through and explain each one of them. Let's see. I don't focus too much on the formal definition. I really like to jump to a little bit of coding. Today, most likely, we won't have time to do some coding, but there is an exercise that you can do optionally, that you can do at home to get this started, and we're going to continue next class with this topic as well, okay? But I'll talk more about what's next a little bit later today. Okay, so we are talking about the first one here, value parameter. Value parameter is any parameter that you just see, actually before anything. Where's the parameter here in this piece of code? Where is it? The parameter, yeah. So display value, here is the parameter. The definition of that parameter, where is it?
Like in the console.write, like the function.
Int x something? Int x. Where's the int x? Is this one here? Where's the definition? This guy here? Yes, so this is the parameter here. So it's just saying that this method is expecting this parameter. Why it's a value parameter? Because there's no modifier, there's no keywords before int here. You see, it's just the type and the identifier. X is the name of the parameter, the identifier of the parameter. Ref parameters, they have ref. Out parameters, they have out. So reference parameters, they have ref. Output parameters, they have out. Parameters, they have params, the keywords. If you don't see any keywords prior to the data type here, this means that this is a value parameter. What's the importance of that? Why do I need to know about that? Well, the only thing that I can say is that when you declare a value parameter, you are actually creating another memory allocation. And when you send a value to it, it copies the original value to this new location here. Whatever you do with this new location does not get reflected where it comes originally from. So here's the example. Becomes a 4 here. We send the 4 here. The number 4 is in this memory address. Think about the memory address as a mailbox. In your building, there are a bunch of mailboxes. If you live in a neighborhood, maybe you have a bunch of mailboxes together. So a memory address is one of the mailboxes that you open and you put a 4 inside. When you declare a value parameter like this, you are opening another mailbox, and when you send the value 4 to it, you are copying that 4 from the first mailbox to the second mailbox. So you're creating a copy. Whatever happens in the second mailbox does not reflect in the initial mailbox. Okay? Again, value parameter, it creates a second memory slot for you and copies the content. Okay? Value parameter and output parameter, it's the same mailbox. Whatever you do with that variable, it will reflect where it came from originally. Let's see some examples here. So, in this case, line 2, what is the value of x right here? 4, correct? 4. And then it calls the method. The method runs, what is the value of x right here? Because now we're dealing with this new value here. But then it comes back, and it writes the third line. What is the value of x right here? 4. Because the value that we have modified here, it has a different memory address as compared to the original one. So we are modifying. So again, address for 2000, address 8000. We modify here, it doesn't reflect back here. Okay? It's a copy. Okay? Any questions? Let me have a look if there are any questions here. Again, feel free to put questions on Padlet too, okay? I'll keep Padlet open here in the second window, on the second computer here. Okay, so that's really it about value parameter. Now, and this is just the output of the example. Now, we are talking about ref parameter. Very similar codes with a minor difference. Now we are using ref and ref here. Ref when we call the parameter, and ref when we define it. That keyword means that this is not a new memory address. When you create this parameter here, it's still pointing to the same memory address. So if we make changes to the value that comes in, that will get reflected back where we call it from. So let's repeat the exercise here. So here the value is 4, comes to the methods, we write it back here. Now we're calling it number, but we could have called it x as well. What is the value of number right here? 888. Comes back. Now what is the value of x here? 888. Because it was modified inside, okay? That's about it. That's what a ref parameter does. It will reflect the original one. And you can have as many ref parameters as you want. Okay? That's just the output. Now, let's change from ref to out. Ref and out, they are very similar with a minor difference. Out parameter, you don't set an initial value to it. Out parameter are just supposed to output. they don't come in with a value. You don't initialize that value. In this case here, look at this. We declare them, but we don't initialize them. So now I can use the keyword out to only output whatever this method is doing with them. So output parameters, we don't care about how this is coming in. We don't care about its original value. We just care that they will be able to carry out some sort of value. Okay? Ref parameters, we care about the value that is coming in. We may want that value. We may modify it, but we may want it. However, with output parameters, we only care about what comes out of it, out of the method. We don't care about how, actually, not only don't care, but it should not be initialized. It's a parameter that it only comes out of it, out of the method. Now, that method is, what is void here?
Because it will not return the method.
It will not return any. So the methods will not return a value on its own. But it could. We could return an integer here. So why not just return an integer here instead of output parameters? What is the limitation of just making this as an integer?
You can return only one value.
Yes. So you can only output one value. Now, if you by any chance need to output many values, and then you're going to use output parameters or ref parameters. Again, the only difference between ref and out is that ref, you don't care about an initial value. Out, you don't care about initial value. Ref, you care about initial value. Okay? But in the end, they use the same memory location. They behave quite similarly. Yeah. Okay? Okay. Yes.
Suppose we have initialized first that value, then will it throw any error? Or
Yes.
Or it will execute?
Actually, I'm quite sure, I'm 99% positive that it will throw an exception. Sorry, not an exception. It will not even compile. So again, if you are using out, you cannot initialize them. You cannot. If you try, it will not compile because it will say, oh, you are using a variable that has been initialized. So for out, you cannot even, you have to declare them, but you don't initialize them. Okay? Okay. Let's have a look at this here. Yes.
Sir, and if we use the void int, it will return one value or it will be throw an exception.
If you do what?
So like you have said in the method, we use void instead of it.
If we use void where? Here?
No, sir, it's the void input method.
Okay, so we're talking about, okay, void input method. Okay, carry on.
If we use instead of void
If instead of void we put int, yeah, if you do that, that's fine. It has to return something. But it will not impact on the parameters here. The parameters will still behave the same way. The only thing is that, again, at the very end, we have to return some sort of an integer.
only single.
Yes. Okay? Yes.
So we generally required to use int instead of void if we want to return to the main method.
So if you, instead of void, you put integer,
Yeah.
what is the question? What is the question again?
So if I use int instead of void here, it will return also.
If we're using an int instead of voids, the only difference is that at the end, you have to return some kind of integer. Because then your method needs to return something as well. Aside from the output, because this will behave the same way, your method needs to, we have to write at the very end, return something, some number. Because again, if you don't set it as void, if you set it as a type, when you do that, you have to return something out of the method from using the keyword return. Make sense? Okay. Again, just the output of our example. Let's have a look at the book author talking about ref and output parameters. Let's have a look at her video here.
Hi, this is Joyce Fair. I'm going to show you how to use ref and out parameters. Here's the main method for a short payroll program. It's got variables called rate and pay, and a constant for 37.5 hours in a standard work week. It calls a getRate method and returns a value to the rate variable. The getRate method returns a double, which is then stored in rate. The getRate method declares its own local variable named payRate, prompts the user for and receives a payRate, and returns the payRate back to the main method where it's stored in rate. Then in the main method, rate is multiplied by hours, producing pay, which is then output. If you use an out parameter, you can eliminate returning the value from getRate to a variable.
So just, again, if you change from voids to, let's say, a double here, like it is right now, you need to have the return. So just going back to your question back there, okay?
Variable. Instead, you pass rate to the method, but precede it with the keyword out. This means that the method will get a reference to, that is the address of, the rate variable. The getRate method then can be void. It doesn't need to return anything, but it needs to accept an out parameter. The keyword out has to precede the parameter name. Once you've done this, then within the getRate method, you can eliminate the local payRate variable and...
What is the error that is in this code right now? Focus on the method's signature, on the method definition. What is the problem there?
We have to write out before the
Yes, yes. So this out here should be before, okay, out should be before double. She'll do the same thing with ref as well, so I just want to highlight that to you. It's a little problem here with the video, okay?
you don't need to return it.
Let me just come back
Once
here.
you've done this, then within the getRate method, you can eliminate the local payRate variable, and you don't need to return it. When you execute this program, main starts, the variables and constant are declared, and then rate is passed to the getRate method. Its reference is passed, its memory address. Therefore, the same location in memory where rate is stored is now referred to as payRate within the method. You prompt the user for and get a value. Let's say it's $12. When the getRate method ends, the reference payRate no longer exists, but 12 has been stored in rate, which can now be multiplied by hours, producing pay, in this case $450, and then the output can be produced. You can use a ref parameter just like an out parameter. If the rate already had a value for some other reason, then you could change out to ref. You use an out parameter when the variable doesn't have a starting value. You can use...
So, listen to that. She says, you can have out parameter if there's no initial value, but if there is an initial value, you use ref parameter, okay?
Use a ref parameter when it does have a starting value. In the method header, then, you change out to ref, and the method works exactly the same way as before. It receives a reference to the original value. Thanks for watching.
Okay. I see a question there. So, let's see here. We can initialize the out variable, it compiles and runs successfully. So we can initialize. Okay. So I'm assuming that you tried that. However, I don't think that variable will be accessible within the method, okay? So if it compiles, that's fine. But again, I don't think that the value of out initially will be accessible. Why do we use ref or out parameters? Well, I'm going to say that one more time. With out parameter, you don't care about the value that it comes in. With a ref parameter, you care about that value, the initial value. That's really the difference here, okay? Why do we use ref? What is the main purpose? So again, based on what I just said, if you still have a question, keep going, but that's really it, okay? Ref, you don't care about the initial value. Ref, you care. That's it. Yes.
They use like basically to reduce the code like lines of code.
You can think that way. Yeah. Okay.
Like we are like giving generally the instead of using the local variables, we are using instead of like coordinates.
Yeah, both of them are using local variables in any case. However, again, one does not have to be initialized. The other one has to be initialized. Okay? Has to have an initial value. Okay? Okay. Okay, here I'm going to give you an example. Actually, let me just step back for a second. Very rarely in my career, I have used ref parameters and out parameters. Very, very, very rarely. Not because I did not try, but because sometimes, most of the time, I just had one value being returned from our methods. But yeah, so I have not used them too much. But there are some methods already pre-built in C# that use out parameters, like try-parse. Try-parse is a very interesting method that is available for integers, for doubles, for any type, any numeric type. What is interesting about that is that it tries to convert a string to a number, to an integer, to a decimal. If it's able to, it returns true. If it's not able, it returns false. Let's have a look at this here. Not only that, but try parse, look at this here. You have integer, int, try parse. I'm going to use the pointer here. So you have int, try parse, and then you have the entry string, which is a variable of type string. What is stored here? Well, the user will enter that. You see, enter your test score. The user can enter a number, but the user can make a mistake as well. It can enter some letters there, some characters there that are not numeric characters. So what try parse does is it tries to convert the string to, in this case, an integer. If it's able, we have the output in this variable here, the converted value. If it's not able to, it returns false, and score does not change its value. The score remains with the original default value there. When you declare an integer, what is the default value for that number? It's 0. So if I run this code and I type test, what will be the score right here? 0, because it will have the original value. If I type 10, what is the score? 10, okay? Now, it's not used in here, but try parse is a method that returns a Boolean. If a method returns a Boolean, how else could we have done this code here if it returns a Boolean? We could have put it in an if statement. You could have said if int.tryParse. So if it's successful, do this. Else, ask again. We could even put that into a loop and only leave the loop after you enter a correct numeric value. So again, try-parse, not only it outputs the converted value, but it returns true or false. Okay? We can use for any numeric types, and I think that from other types as well. And I don't know if Boolean has a try-parse, but it could be int, it could be decimal, it could be float, it could be any numeric value, any numeric type. Okay? Yes, you can do if int.tryParse, and again, it will return true or false, and you can have an if and else statement. Okay? Okay, so we have a question here. Are there any real-world applications which use out? I just show a method that uses that. And that method, to be quite honest, we use that quite a lot when we're trying to validate what is it that the user is inputting. Okay? We use that quite a lot. So yes, this is a real-life application of try parse. We're going to be using that quite a lot as well in our own tests, in our own codes. Okay? So it cannot be more real than this. I can tell you one thing. I will not be talking about things that are not useful, that are not usable, that don't have any application out there. Okay? Again, this is just the test output. And we're going to wrap things up with parameter array. Now, don't worry if parameter array will not become very clear at first. That's fine. We're going to be doing some exercise about that from the exercise that I made already available on the Centennial and from more exercise that we're going to be doing in class. So, again, don't worry too much if it's not clear at first. Better is really to go hands-on and give it a try. But parameter array, if there is any type of parameter that is complicated, this is the one that is a little bit complicated. Why is that? Well, because with parameter array, you can send parameters to the methods in many different ways. Look at this example. We have declared, what is this? What is the string brackets here? What is that? What does that mean? It's an array. Array of what? Of strings. So we are declaring an array of strings and we are defining its initial values, okay? We are adding 4 strings to that variable. And then we are calling display strings in 3 different ways. We are calling the first one just with one single constant string, just one single fixed string. The second one by using comma. So we put one, comma, the next, comma, the next. We can put as many as we want there. And the third one, we can actually send the variable of type array. So again, we can send it in multiple different ways. One quick thing about params is that first, it uses the keyword params. Okay? Second is that the type of the variable needs to be an array, needs to be defined as an array. It can be an array of integers, an array of any type, but it has to have the square brackets to define that this is an array. Let me ask you this. Forget for a second that we have these params here. Get rid of that. Which one of those method calls would fail if we don't have these params here? If it was just an array of strings, people, which one would fail here? Which one would fail, would not work? The first one, what is this? One string. What is this? 3 different strings. This is not an array. This is 3 different strings. And what is this one? This is the array. So only the third one would work if we didn't have params here. If it was just one parameter of an array type. But because it's a params of array, all 3 of them can work. You can use commas, you can send the type as a string of arrays. All of them will work. A few other key aspects of params is that, first, you can only have one of that in a method declaration. Just one params. You cannot have 2. Think about the mess that it could be if we had 2 params of strings here. It would be very messy. I mean, when is it that the first one finishes and the second one starts? again, it will become hard to figure it out. So it can only happen once in the parameter list, and it has to be the very last one. Go ahead.
If we are having two type difference, then we are having one string and one integer array parent, then also we can't.
It won't work either. It can only have one params per method declaration. Okay? And again, if we had, let's say, another parameter called x, int x, we have an x that we want to send it. It cannot go in the end of the list. It has to be the very first one. It has to be before the params. Okay? So I'm going to repeat that. Params can only be one per method, and it has to be the last one if we have more than one parameter. So again, if we want to add an integer x, it cannot be at the end, it has to be at the beginning. And the way you go through this list of strings is just with a for each loop. You can just loop through it, okay? And it will read all of the input, regardless if you have 1, 3 with commas, or with comma, or one argument as an array of strings. As I said, this may come across as a little bit confusing. Let's see here, what is the difference between using the word params and not using? I just said that. I don't know if you catch that. I just asked that, what is the difference if I take this away? If I take this away, we just have one parameter that is an array, so only this one would work. Not this, nor this, okay? I'm just looking at the question on Padlet. Okay, so this is just the output. I'm not going to get to method overloading. We are already overloaded with stuff, okay? So let's leave overloading for next class. What I want to do quickly here is just to mention what is already available on Centennial in terms of assignment, in terms of bonus one. Before I do that, can you please go to Centennial? And I would like to check, because some people reported that they could not see the bonus assignments. Can you go to assignments, assessments, and assignments? Can you tell me if you can see bonus 01 there?
Yeah, it's in week 1. It's been uploaded to week 1 instead of into the assignments folder.
That's okay. That's okay, because it's not, yeah, that's okay. Well, that's a good point as well. Usually the bonus I put for each week under the week, but you have a point there. I may rethink about that. But in any case, the bonus document is under week 1. I'll go back there in a second. But I just want to confirm again, can you see bonus 01 in your assignments? Can you click there? And are you able to upload a file? Just want to have a quick look. So yes, add the file so you can do that. Okay, great. So I think it's working. Just someone mentioned to me that it was not working for him. Okay, so first thing I want to mention about bonus 1. Can you please go to content? Scroll down, go to week 1. My goal is to have every week to have a bonus, but let's see how this flows. So scroll down, you're gonna see my introduction, class commitments, you're gonna see week 1, day 1, week 1, day 2. Those were the 2 PowerPoints that I have covered today. I see someone writing a question there on Padlet. On Padlet. I will look at that in a second. If you want to get hands-on with this content today, you can have a look at week 1 exercises. There are 2 simple exercises there. You can give it a try. We're going to be talking about that next class. But in terms of the bonus, you can download this Word document, download it. You don't even need to change its name. Keep the same name, download it. Then you're going to address those 2 points. First point is about the podcast. As I said, I'm going to be using the podcast here for your benefit. Pick any episodes. We have from episode 1. Don't pick 1 because I'm just rambling there. Pick from episode 2 up to episode 20. Pick 1, just 1. Listen to it, and then tell me which one you picked. Tell me one thing that was interesting. If there's no interesting thing there, no, pick anything anyway. Pick a boring one. And the last point, What question would you have asked the guest that I did not ask? What would you be curious about that person that for some reason I didn't ask? Okay? Think about that. So, as I said, download to your mobile device. You can download at home. You can listen if you're driving in the car, if you're commuting the bus. It's 30, 35 minutes. So it's really, unless you are around the corner, otherwise you are driving or commuting here, it will take, at least half an hour. What I can tell you as well is about this course. This course, I don't know if I mentioned that, but this course requires you at least 2 hours outside of class. So it's a 4-hour course per week, but you should plan to put at least 2 hours of effort outside of class on your own time. Okay? Second point, watch those 2 videos. Those are not my videos, but they are related to to next week's content. Each video has about 5 minutes, and then ask 3 questions about the video. Something that you didn't understand, something that you would like to get more information. But make sure that this is relevant to the videos. Don't ask me about the weather, okay? It has to be relevant. That's it. The third point is just about, you save it, and then you upload under your bonus 01. There is no right or wrong answer here. Now, again, it has to be related to the topic. Don't upload it blank. Don't upload it with something that doesn't make sense. I'll be opening here in front of everybody, so you're gonna be outed if you do that, okay? Again, this is the flipped classroom thing that I talked about. You come to the next class with some basic knowledge about the next week's content, so we can advance from here. You don't start here from scratch, okay? Okay, so I see a few questions there. Let's see, what is the difference? Okay, that's done. In the example, we only have string type in the array. What happens if we have, okay, let me flip here. In the example, we only have string type in the array. What happens if we have different data types within the array? Like, okay, so if we have different data types, the array is an array of objects. That's fine, that's okay. Remember, arrays, it has only one type. It can be a high-level type like object, which can store strings, strings, integers, any object. But again, it has to be one single type. You cannot have an array of strings, and all of a sudden you put string, number, objects, okay? I don't know if this makes sense, but you don't have, in an array, you don't have different data types. Arrays is one single data type, okay? Well, let's compile, int out, okay. It should compile. I don't see why not. Void, yeah, I don't see why not. Did it compile? I mean, whoever asked this, I mean, I don't see why it would not compile. No, actually it does not. It does not, and here's the reason. Void, no, okay. So hold on a second here. So out cannot be, you cannot have a parameter, void parameter. It doesn't make sense, it does not make sense, okay? Parameters, they have to have a type. They cannot be voids. So this doesn't compile. Have you given an assignment? That's what I'm gonna do right now. Perfect timing. That's the next point. So, any question about the bonus? Again, bonus is the one thing that is not negotiable. I don't negotiate about bonus. You have to get it done before the beginning of the next class. Don't come to me saying, can you open the folder again? No, I cannot. I don't negotiate about the bonus. Yeah, I get it, we get sick, and I get it, that. But again, I don't negotiate about the bonus. I do not. I mean, everything else is negotiable, not the bonus. The bonus, you have a week. This is not, well, you're gonna need a good chunk of time to do that, but again, it's not negotiable. I want to make that very clear. Okay, so assignments. Let's go back to content. Assignments. Then the first one here. The first one is about this, is about ref parameters, out parameters, just about that. You can check the due dates of the assignments in the folder, in the assignments folder. Let's have a look there. Assignments. So assignment 1 is due on Jan 24th, 11:30. So usually the assignments, the due dates are the Fridays of a certain week at 11:30. So that's due in 2 weeks, okay? So again, it's about this content here that we just went through. There might be a thing or two about parameters, 3 exercises, and that's it. What you're going to do is you're going to write 3 applications, 3 little applications. Here's the description of what you have to write. 3 solutions. And by the way, I didn't show you this, but I'm going to show that in a second. Then you zip them up, and you upload that to Centennial. That becomes your assignment. You upload that under the assignment folder. Okay, so you're going to have the assignment 1 folder there. Quick note, I'm just going to open here quickly Visual Studio. How you get to create a new console application? Very simple. Go to File, New, Project, and then select Windows Desktop, select Console App.NET Framework, and then you give it a name. Let's say My App 03. And then that's it. Then you can build your code there. Again, next class, the idea is to start with hands-on and be way more hands-on than this, because this was not hands-on. And I don't like not hands-on class, but again, we're going to start to do things a little bit different after the first week, okay? I see some questions here. Let's see. Okay, gave an assignment? Yes, I just gave. Assignment is related to the code today? Yes. Or should we do it after second week? No, you can start doing your assignment. The content that I covered today is pretty much enough to cover the assignment. If you have questions about the assignment, again, drop me an email, drop me a note. If you're stuck with something, let me know. Where do we get Microsoft Visual Studio from? Okay, I will post today, I promise, a link to a document that shows you where you have to click to download Visual Studio, okay? Check again later, latest tomorrow morning, you're gonna see a link on Centennial, either on the week, most likely on week 1, where to download Visual Studio, okay? I'll do that today. Okay, this exercise, okay, can we change the submitted assignment update or delete? Can we change the submitted assignment? Actually, if you submit something there and I don't know, maybe you submitted too early, maybe you submitted the wrong file, you can upload another one. I won't consider the last one, okay? If that's the question. I won't consider the very last one. I'll ignore the older ones, okay? 3 exercises are in one solution. You can do in one solution, you can do in 3 different solutions as long, okay, so here's the tricky thing. If we put in one solution, I would have, for me to check, I would have to change the codes. So make it 3 solutions, okay? Make it in 3 different solutions, okay? Yeah, because you see, okay, let's see here. Let me see here. See, sorry, I mentioned it wrong. What I meant is this. It has to be 3 different projects, not necessarily 3 different solutions, okay? So again, there's a difference between project and solution. A solution can have multiple projects. So if you want to do one single solution with 3 projects, that's fine, okay? If you want to do 3 different solutions with 1 project each, that's fine as well, okay? Okay, let's see, there is another question there. Okay, so again, Visual Studio, I'm gonna get back to that. 3 exercises are in, okay, great, I explained that. Can you explain instructions for assignments? Okay, read the instructions. The instructions are very clear. Again, if you have questions about instructions after you are done reading, let me know. But again, use a little bit your reading skills there, okay? Is assignment 1 10% wage in the final grade? Yes, it is, okay? Yes, it is. Again, individual. What is the due date for assignment? The due date is listed under the assignment folder. So go to assessments, and then you're going to be able to see it in the far right, okay? The due date will be there, but here it is, January 24th at 11:30 p.m. Let's see if there's any other questions. Okay. How can we get the software register version? That's what I just mentioned, that I'll be uploading, I'll be pointing you to where you can download Visual Studio using your eCentennial credentials, okay? Because we all have access to that. I will provide that, okay? It will be under week 1. It's not there yet. What is the due date? Are we required to put screenshots of programs or... Okay, let's see. Or Word file? No, not for the assignment, okay? No, the assignment will only require you to upload the project. That's it, the project files, okay? The solutions. Okay, anything else? Okay, we survived the first week. Okay, great, awesome. Have a good weekend, and I'll see you next week, okay? Let me know if you have any questions via email. I'll be always available. Thank you.